So each dot on the bootstrap sample that we saw from the previous one is going to be just the sample statistic from a bootstrap sample that they took. So if he repeatedly took a random sample from the original sample over and over and over again with a placement, he's going to get a bootstrap sample. We just want to know what's the average of that bootstrap sample. So the correct answer would be B. So the mean increase in insurance costs for the sample of 10 policy owners taken with replacement from the original sample. 26 says, what is the 95% margin of error? So what we want to do is we want to go back and look at our bootstrap distribution, and we see that the standard error is about 55.5. So to find the margin of error, that's going to be just twice our standard error. So it's going to be 2 times 55.49, which is going to give us 110.98. So the correct answer would be D. 27 wants us to give the upper and lower limits of the confidence interval. So you want to remember the basic formula for any confidence interval is just the statistic plus or minus our margin of error. We're going to take our best guess, which is our best estimate or sample statistic, and just figure out about how far off we think we are. So we believe we could be off by about $111. So we're going to take our sample statistic, which was 45.90, and then add and subtract 110.98, and that's going to give us negative 65.08 up to 156.88. So what that range is going to do, it's going to give us what we believe the true increase in price from going from local to the online price quotes. So they could save anywhere from about $156 to losing about $65. So 28 says, true or false, I'm 95% confident that the mean increase in insurance costs among all policy owners is contained in the confidence interval. So since it's saying all policy owners, that's talking about the population. So we're looking at the population mean, which is what our interval is going to give us a plausible range of. So 28 would be true. And then 29 says, I'm 100% confident that the mean increase in insurance costs among all policy owners in the sample is contained in the confidence interval. So that's the key part here, is that our sample statistic is always going to be inside of our confidence interval, because that's where we're starting. We're just going to subtract from it, we're going to add to it, so our statistic is always going to be in the middle of it. So we can be 100% confident that X bar is inside of this interval. So that statement would be true. So if the insurance agent wanted to decrease the width of the confidence interval, what should they do? So they could basically just want to take a larger sample size. The larger and larger sample that he has to begin with in his original sample, the smaller and smaller the standard error is going to be, because our sample statistic is going to get more and more accurate. So increasing the sample size of the bootstrap distribution isn't going to do anything. Just going to kind of give us a better picture of what the bootstrap distribution looks like, but it's not going to affect what the standard error is. So we just want to increase the number of policy owners in the original sample. Decreasing it would just make it wider. And then based on the confidence interval, is it plausible that, on average, the policy does not increase between going from local to online? So, since 0 is contained in the interval, then we're going to say that 0 is a plausible value that the mean could be, that somebody could not save any money going online. So the correct answer would be yes. So our sample backs up his claim that going online doesn't actually save you any money.